Hey there, science enthusiasts! Today, we're diving deep into the microscopic world of atoms, the tiniest units of matter that make up everything around us. Let's kick things off with the basics. An atom is like the Lego block of the universe. It's super small, with diameters ranging from 0.1 to 0.5 nanometers. Inside every atom you'll find a nucleus made up of protons and neutrons, surrounded by a cloud of electrons. Think of it as a tiny solar system, but way cooler. Now let's break down these atomic subparticles. First up, protons. These are positively charged particles hanging out in the nucleus. Each proton has a charge of +1 and weighs about 1 atomic mass unit. That's roughly 1.67 x 1027 kg if you're into the nitty-gritty details. Next we have neutrons. These guys are neutral, no charge at all. They're slightly heavier than protons but still clock in at about 1 atomic mass unit. Neutrons don't mess with the atom's charge but do add to its mass. Last but not least, electrons. These negatively charged particles zip around the nucleus at lightning speed. They're super light, about 1/1836 the mass of a proton, or 9.11 x 1031 kg. But don't let their size fool you. Electrons are crucial for chemical interactions. So, how did we discover these subatomic celebrities? In 1897, J.J. Thomson was tinkering with cathode ray tubes, think old-school TV tech, and discovered electrons. He noticed rays bending under electric fields and figured out they were tiny, negatively charged particles. His plum pudding model got updated later, but it was a solid start. Fast forward to 1917 to 1919, and Ernest Rutherford made the proton discovery. After his famous gold foil experiment, he realized the nucleus had a positive charge. By bombarding nitrogen gas with alpha particles, he confirmed protons as the positive culprits. Then, in 1932, James Chadwick discovered neutrons. He noticed atomic masses didn't add up with just protons and electrons. By firing alpha particles at beryllium, he produced neutral radiation that knocked protons out of paraffin. Voila, neutrons. Alright, let's talk about electron arrangement in an atom. Electrons aren't just floating randomly, they're organized in energy levels or shells around the nucleus. Here's the gist. Shells are labeled by numbers, n = 1, 2, 3, etc., starting closest to the nucleus. Each shell holds a max number of electrons, calculated by 292. So, n = 1 holds 2 electrons, n = 2 holds 8, and so on. Inside these shells, electrons occupy subshells, S, P, D, F, with different shapes and capacities. For example, the S subshell can hold 2 electrons, P can hold 6, D can hold 10, and F can hold 14. Electrons fill from the lowest energy level up, pair up with opposite spins, and spread out before pairing. For instance, carbon with 6 electrons has 2 in the 1s subshell and 4 in the 2s and 2p subshells. This arrangement dictates an atom's chemical behavior, like why sodium loves to lose an electron, but chlorine's dying to grab one. It's all about filling or emptying those shells. Thanks for tuning in, and don't forget to subscribe, like, comment, and share. Alcee Mai loves you. See you next time.